As engineers, we often have to do calculations kind of repeatedly, and we like to implement that in a way where we're not having to recreate the calculation every time. And that's where tools like Mathcad and Python can be a strength, but we're often faced with this dilemma. Do we go down the Mathcad path where we have units that are handled for us and intuitive user interface, or do we go down the Python path where we can pretty much do anything we want, but it becomes very difficult to read. It's hard for others to kind of build off that, hard for others to check. And so we're faced with this dilemma whenever we do a calculation. And oftentimes, once we go down one path or the other, it's hard to change. But this choice with EngineeringPaper-xyz is no longer there. You get to do both. You get to have the intuitive user interface with units tracking, units checking, and you also get to pull in Python when necessary. So let me show you what I mean. So with Engineering Paper, it's designed to work without code most of the time. So you can do units, you can do complicated expressions, you can do plotting, you can have things that have if statements, basically select tables, you can do data tables to do kind of spreadsheet-like things. So it's designed in piecewise expressions, which are basically if statements that are kind of built into the language, like shown here. So you can do a lot of logic without having to do any code, but occasionally you do need to do something that Engineering Paper isn't capable of, and in the past you had to kind of abandon the tool at that point, but not any longer. Now we have code cells. So what's a code cell? So basically a code cell is a piece of Python code. It has a function called calculate in it. So Engineering Paper is looking for this function, so you always have this function called calculate. It has inputs, and you just return a value. So it gives you a kind of a basic bare bones calculation. We're taking value, multiplied by 2, and returning it. Now this is, just showing you the structure, and we'll show you some examples of calculations that you would do that to extend the capabilities of Engineering Paper. Part of the code cell, there's 3 components. You have the code, which is pretty obvious. You have this code cell, what's called a function definition. So basically what's telling Engineering Paper, again, always keeps track of your units. So you need to tell it what units your function can accept. This is using any, so it'll accept any units, and it's returning none, so the result has no units. If you need the specific units, we'll show some examples where you can put units into this function. Basically, any will take your value, it'll accept any units, but it's going to convert it to the SI equivalent, do your calculation, and return a value and give it no units. Okay, and we'll see different examples. And here, if we have more than one input argument, we'll separate those by commas. So this is easiest to illustrate with the calculation. But one thing we'll point out here, Engineering Paper itself is powered by Python. And this is really what this code functions is doing, is giving you, the user, the access to the full computation engine that an EP already uses anyway. All this Python is running in your browser. So basically, we're running in a Python environment in your browser using Pyodide. So it's giving you versions of Python and Pyodide you have, and you have all these powerful libraries available to you. So all the calculations in Engineering Paper use SymPy. So you have SymPy available. We'll see how to use that. You have polars, pandas, NumPy, SciPy, scikit-learn. So a lot of powerful libraries at your disposal. Matplotlib, we'll see how to use that as well as you do your calculations. So let's do a simple one. In Engineering Paper, we have some built-in functions. We have mean, or average, but we don't have median. So let's see how we'd add a median function. So we'll call it median. We call our functions whatever we want. We're going to allow any units as input. And these can be scalar or matrix, as we'll see. In this case, we'll do a vector and do the median of the vector. And then we want our result to be unitless. Okay. Right now, we're not going to use SymPy mode. We'll show what SymPy mode is in a second. All right, so to do the median, it's in the Python libraries for statistics. So if I do import, I could import any libraries I need to use. So I import statistics. That's what Python calls its statistics library. And so I'm just going to call this values because it's really going to be a vector. So I'm just going to change the name to reflect that. Though this function calculate has to always have the same name. If I change its name, it's going to say you need a function called calculate. And so I'm just going to apply the statistics. Actually, let's do this. I'll do from kind of any normal Python format is going to work. You can use large language models to help you generate these functions. That works pretty well. From statistics, I'm going to import median. Okay, so that's our median function. Now, when I do this, there's a lot of code helps that you're kind of used to when you're using coding tools. So if I hover over a name, it's going to give me some information about it, this function. So median is going to explains this median function. So what I'm going to do is this is a pretty simple function. I'm just going to return the median of values. Now values is a vector, so to tell Python to unwind that vector into a series of values, I'm going to use a star function there. And that's kind of standard Python notation. And so I'm going to convert basically a list into a series of arguments. So I'm going to do median. Let's call this function, and we're going to give it a vector of, let's say, 4 values. So I'm going to do 4, 1, which is the shorthand within square braces to insert a vector. So I'll do that, and I'll say, let's say we'll do 1, 2, 3, 4. Something simple. We know what the median should be. It should be 2.5 in this case. Now it's giving me an error. Okay, so it takes 1 positional argument, but 4 were given. So it looks like median takes a list. I called it incorrectly, so it takes a list. So we give it 2.5 rather than individual values. And so you can see how the error handling, it shows you where the error is, it gives you the error message. So it's designed to be pretty intuitive to kind of match kind of typical coding environments you may have used, similar features. All right, so that's a median function. You've added a median function that didn't already exist in Engineering Paper. Let's look at a different example. So what's this SymPy mode thing? Let's do some symbolic manipulation. So basically, when you're not in SymPy mode, like in this example, your inputs will be, in this case, it's a NumPy array. I can actually print values, and when it calls that, it's going to print it below the code cell. This is good for debugging. So you can see it's a NumPy array. I could learn more about it, do type, use the Python function type. Type of, missing closing parentheses. So I can see when I call type, it gives me the numpy.nd array as the type. So I can do this, it's useful for debugging. So I can see that when I give it a scalar value, it gives me, when I give it a vector, it turns into a NumPy array. So all this kind of handling of scalar versus arrays kind of happens automatically. So let's see what SymPy mode is. Let's do a second function. So SymPy mode allows us to operate directly. Everything internally in Engineering Paper is SymPy expressions. And let's do a factor function. We'll use SymPy mode. So now the values passed to our function are going to be SymPy expressions. So that has an advantage that we can do symbolic manipulation, not just numerical computations. In order to do this, we need to import SymPy. You need to import, we'll say as SP. You need to import in every code cell. Every code cell is in its own namespace, so they can't interfere with each other. So if I need something in multiple places, I need to import that in multiple places. There's not really a performance penalty to that. Python only really imports it once. It just keeps a reference to it. So here I'm going to return SP. Now if I hit dot, it gives me autocomplete. If some situations autocomplete doesn't show up. So let me show what I mean. So if I do factor, and if I'm in here, it's not doing autocomplete. If I go do control space, it'll give me autocomplete. It only shows up by default after hitting dot. And so what's this going to do is apply the SymPy factor function to, that doesn't make any sense, to our input value. So what does this do? So if I do a polynomial, so x squared plus 5 times x plus 6, like normal, Engineering Paper handles symbolics just fine. But let's say I want to factor this, right? And so that's what this function is going to do. So I do factor, the same expression. I can just copy it here. Right? Now, right now, it's not doing anything. And the reason for that is Engineering Paper has its own default simplification that it does. So we need to turn that off. So if you want to do any of your own manipulation, you need to turn off. I go into settings, automatically simplify symbol. It's just doing a very simple, it's basically just canceling equal terms. It's just a kind of low cost simplification. But if I want to do something else, I need to turn that off. And now whatever simplification I'm doing, it gets enforced. So I can do things like factor, which is not currently possible in Engineering Paper without a code cell. So that's SymPy mode. I'm dealing with SymPy expressions directly. All right. So what if I want to output a matrix? Let's just keep adding code cells here. Right now, Engineering Paper doesn't have a random function. So let's say I want to generate a random a matrix of size with a certain number of rows and columns. So I need to put two input parameters. So I'm going to do any, any. I'm going to do this in NumPy mode right now, or not in SymPy mode. So I'm going to import NumPy used the NumPy rand function. Let's do as MP. So right now it's giving us an error. It tells us what's wrong with it. It says calculate function does not match the number of inputs. So I have two inputs. I need to put, we'll say, num rows, num columns. So again, we can name our input parameters what we want to be informative. Again, the function has to be calculate. So I just want to return a random NumPy array of that size. So I'll do return. We'll do MP. Again, the autocomplete will be there. It's the random module of NumPy. And the function is called rand. So I'm going to do num rows. NumPy is a little weird. Sometimes it wants matrix dimensions in a tuple. In this case, it wants it as arguments, so it's a little different than normal in NumPy. And so right now, let's call this function. I can copy my function name by hitting this copy button here. I can do Control V, and let's do a 2x3. Hit equals there. Uh-oh, we got an error. So float object cannot be interpreted as integer. So what's happening here, I'm not in SymPy mode, so these are all going to be floats. And so I just need to convert these to int, because NumPy wants this to be int. Python treats ints and floats different. They're a different data type. And so that, I'm missing parentheses there. And so now I get my random function. And if I could change the size. So it automatically handles kind of, if I return a matrix, it's a matrix. If I turn a scalar, it's a scalar. So all that's kind of transparent to you. All right, so let's look at some other features of code cells. One powerful feature of code cells is in the rendering capabilities. So you can render text, HTML, or Markdown, and it handles it kind of transparently. Cell. Let's do another code cell here. So if we want to output text, let's do that. We switch the output type to text. Okay? And I'm going to say, we're going to call this function summary. It's going to summarize our result for us, whether it's kind of a pass-fail type situation. We're going to give it a stress, an MPA, and this will address how it handles units. Because so far we've been ignoring the units. So MPA for a value and a threshold, and it tells us the number of inputs has to match. So let's do, we'll call this the value and the threshold. So basically value needs to be below threshold. All right, and so with a text type output, we just return text. So basically, let's do an if statement. We'll do if value is less than threshold. This is a pass situation. So I'm going to return, I can just return a simple string pass. And we'll say that, now I'm going to do what's called an f string in Python, which allows me to reference the values. So pass, so we'll do value is less than threshold of, so this curly braces allow us to inject numbers into this string. All right, so that's a pass condition. And then we have the fail, so the threshold is greater than or equal to. And so this is a good way to have, you can put this at the top of the result of this at the top of your sheet, so you get a good kind of go, no go type situation with some logic. Is greater than threshold. And then I'm going to put units in here, right? So this is also going to show us how code cells handling units. You notice I put MPA instead of pascals here. And what that does is, normally if I put any, it's going to convert to units. It's not going to check the units, it's going to convert them to the SI value. EP always operates on the SI value internally. But if I put MPA here, it's actually going to convert them to MPA for use in my code cell, and I'll show you what that means. We'll put units here. So the units that you put there are important. I recommend generally for functions you just want to have SI units here, so that it kind of eliminates confusion. But for these kind of reporting cells, it could make sense to do. This is the non-SI. SI would be pascals. So let's take a look at what this function does. So if we do, first off, if I don't do the units, let's say 10 is our value and 20 is the threshold. Let's see. So incorrect units for input number 1 of code cell function summary. So basically, I've given a unitless value and I said it has to be MPAs. So let's put, it can be any pressure units, it doesn't have to be MPAs. But what's going to happen, since I said MPAs, it's going to convert it to MPAs before passing it to this function. So I get this tiny number because I put pascals in. Really, I meant MPAs, so I need to put MPAs here. So you can see that inside my code function, it's going to be whatever units I said here, and it'll convert it for an output to from whatever I said for an output unit. Here it's just text, there's no output units. So it gave me pass, 10 megapascals less than a threshold of 20. If I accidentally had too much there, it's going to be greater than. And it's going to say fail. I can add some emojis in here to make it a little more highlight what's going on. So if I do Windows period key here, I can do pass as a green emoji, and I can do fail Windows period key as an X, for example. And so that gives me a little more graphical showing on what's going on there. Now, this is just touching the tip of the iceberg of these render functions. There's a tutorial here that you should take a look at if you're interested in doing, looking into doing these Python extensions, these code cells. So let me open this. So it goes through some similar examples, but it kind of gives kind of the full documentation of code cells through several examples, going into more detail than I went to here. But if I keep going, it shows this example we basically just did. But we can also use HTML. Now, once we open up HTML, that opens up text formatting, it opens up images and figures. And so here's that same example, but now with HTML output. And there's templating libraries. I'm just using an F string. This triple string is a multi-line string in Python. It's sometimes called a template string, which allows you to more easily do like HTML. So here, I'm adding a box, I'm coloring some text, bolding some text, and so it gives me a more kind of graphical, more control over the rendering. But this has even more possibilities here. So because SVG, scalar vector graphics, or images are part of HTML, I can do, in this case, I'm going to do an SVG image. So here I'm using the Draw SVG library, which is included, and I'm going to go all the way down and show you the result here. So here it's showing a 2-arm robot in a Scara formation, kind of a standard industrial pick-and-place robot configuration. And it's showing the work envelope for that robot in shaded in blue here. Now this is not just a static image. If I change the length of that smaller arm, that's going to reduce the area it can reach, and it's going to update that figure to show that. I can also change the angle range. So if I change the angle range for the base arm, let's increase that a little bit, -20, 120 to 120, that's going to increase the envelope. So that gets updated based on the values of my sheet. It's looking at units. I'm doing it in degrees, so that means the numbers come into my function in degrees rather than radians, for example. And so it gives me some powerful ways to visualize graphics. Kind of related to that is I can use Matplotlib. That's included as well. Again, you don't have to install everything. This is all part of the app. It runs in your browser. It's using the Pyodide project. Nothing goes to a server. It's all on your own machine. And so here I could do a Matplotlib plot. There's some little bit set up that's covered in the documentation here because you need to convert it to HTML. And so for an image, there's a certain step you got to go through to do that. Here I'm showing polar plots, again, because Engineering Paper doesn't include polar plots. So I'm showing how you can extend the functionality of Engineering Paper using Matplotlib. If you're just doing kind of normal scatter plots, the built-in plotting would be easier. But if you need to reach to something that isn't there, bar plots, pie charts, things like that, then this will be a powerful tool. So here I'm doing it as SVG instead of, which gives a little nice crisper image if I do SVG rather than PNG for that Matplotlib. So this is kind of giving you a taste of code cells. There's lots that's possible. Kind of try things out. Share what you find on the EngineeringPaper-xyz Reddit page, and or if you have questions or issues you run into, either that or the GitHub either the Reddit page or the GitHub page are the way to kind of get help. All right, enjoy.